Have you ever heard someone say, "Whatever floats your boat"? Well, the answer should always be buoyancy. Buoyant force is the force applied upward on an object by any fluid. Archimedes' principle states that the buoyant force applied to an object is equal to the weight of the fluid the object displaces. Let's take a closer look at this definition. First, we need to understand displacement. As the story goes, Archimedes poured himself a warm bath one day, and when he got in, he realized the level of the water went up. He then determined that the more of his body he put in the bath, the higher the water level went. This means the volume of his body that he put in the water had to move or displace the water so he could fit in the bath. Therefore, displacement in this context is when an object moves a fluid so it can occupy the volume the fluid originally occupied. Let's use a battleship as an example. A battleship is made of steel. Right about now, you may be saying, but steel doesn't float. So how is it a battleship can float? Look at the image of the battleship. Now imagine drawing a line where the water comes up on the hull of the ship. Then fill the ship's hull with water up to that line. How much do you think the water would weigh? If you said a lot, you're right. It would actually weigh as much as the entire ship. The weight of the water to fill up the hull of the ship weighs the same as the ship, so the water applies a buoyant force up on the ship with this much force. Therefore, the ship made of steel floats. Let's look at another example. If you put an ice cube in a glass of water, the cube floats because ice is less dense than water, so the ice underwater displaces that volume of water. To make things easy, we will say that the ice cube is a perfect cube, where each side is 1 centimeter long, as shown here. Let's also say the ice cube is floating, so that 0.8 centimeters is underwater. How much does the ice cube weigh? To determine that, let's go over some calculations. Remember that Archimedes' principle states that the weight of the fluid displaced is the buoyant force. Therefore, we need to know how much water is displaced. If 0.8 centimeters is underwater, then we can find the volume of that shape by multiplying the 3 sides together. In this case, we only want the volume of the cube that is underwater, so we multiply the length and width by the amount of the height that is submerged. V equals 1 centimeter times 1 centimeter times 0.8 centimeters. Multiplying 1 times 1 times 0.8 gives us 0.8. Multiplying the units gives us cubic centimeters. V equals 0.8 centimeters cubed. Since 1 cubic centimeter is 1 milliliter, we can directly convert to volume in milliliters. Volume equals 0.8 milliliters. The density of the water is 1 gram per milliliter, so the mass of that much water is 0.8 grams. M equals 0.8 grams. We're not done yet. Mass is how much stuff there is in something, but weight is the force that stuff pushes down on the earth. To find weight from mass, we need to convert the mass into kilograms. A kilogram equals 1,000 grams, so we divide our mass by 1,000 to get 0.0008 kilograms. We then multiply by the Earth's gravitational constant, which is 9.8 meter per second squared. This will give us the weight of the displaced water in newtons. 0.0008 kilograms times 9.8 meter per second squared equals 0.00784 newtons. Archimedes' principle is that any object that is surrounded by a fluid is being lifted up by that fluid. This lifting is the buoyant force, which is equal to the weight of the fluid the object displaces. Therefore, the more displacement, the more the buoyant force, and the heavier the liquid, the more the buoyant force.